Our lab tries to understand the interplay between heat transfer and fluid dynamics. So what that means is we're interested in fundamentally understanding really the underlying physics of a droplet, for example, and how it interacts with a surface, how it moves when it impacts a surface, how it deforms, how it might bounce off a surface. In the presence of different temperatures in the system. Really a big motivation of what we're doing is climate change. So we just need to get better at using resources more efficiently. So that ranges from power generation all the way to cooling spaces. And a lot of those processes actually involve thermal processes. So there are a lot of good reasons to come to WashU. WashU is a very collaborative place, very open, friendly people. Almost everyone that I've met was extremely helpful in helping me start when I was here first, and I also see that with my PhD students. It's a relatively smaller school, which means there is more attention to the individual PhD student. They're really not just numbers or names, they're actually people. We have a rotation program for the PhD students. So students up front, once they're admitted, they don't have to decide yet on which lab they go to. They can actually rotate into different labs and try out what the research is like, whether they enjoy the research, whether they enjoy the mentoring aspect that they get from a certain professor, because each of us obviously has a different approach to mentoring. So I think both from a faculty side and from a PhD student side, that's a really big advantage because there is this time to really figure out whether it's a good match.
Currently, the research that I'm working on is non-isothermal multi-phase flow in porous medium, specifically emulsion flow. Emulsion is a dispersion of a droplet in continuous liquid. And in immersion flow, usually the droplet is going to be clogged in a pore throat, and this process will change the entire, will change, or at least it will redistribute the entire flow field. But the transport phenomena of this process is not clearly understood, how the microscopic flow dynamics is affected and how the macroscopic convectivity transfer is affected. So on this research, we're seeking to understand the fundamental transport phenomena in how heat transfer is going to influence the flow dynamics at pore scale level using high-speed and infrared cameras. Advice for any incoming new PhD student is do not decide which lab that you're going to end up whenever joining WashU, and I strongly suggest that they're going to utilize the rotation program and to find a lab culture, to find a research that they're interested in, because that might surprise them, to be honest. They might end up joining different labs, they might end up liking different type of research, and passing on that opportunity is what I don't suggest to them.
My research is focused on water condensation on engineered functional surface. Condensation is a universal phenomenon in daily life and is widely used in industry applications. In our research, we want a higher condensation rate, so we design surface and study the fundamental physics underlying the condensation phenomenon. And with this better understanding of condensation, we can control the parameters such as design surface roughness, modifying the properties, finally to achieve a higher heat transfer rate.